Hello, my name is Maggie Manning, and this is Frank and I's project on our molecular molecule for the Gen Chem Lab 1112. Our molecule that we got was ethylamine, which chemical's formula is CH3CH2NHO2. So an introduction about ethylamine, which chemical formula can also be simplified to be written as C2H5NH2. So let's begin with the 2D molecular structure of ethylamine, which is also known as the Lewis structure. So as you can see, the Lewis structure is depicted below. There are 2 carbons, 7 hydrogens, and 1 nitrogen. Each carbon donates 4 valence electrons to ethylamine. So in total, they donate 8 valence electrons. There are 7 hydrogens as pictured, which each donate 1, as you can tell by the bonds, donates 1 valence electron, which in total is 7 valence electrons. And on the right, there is 1 nitrogen, and 1 nitrogen can donate up to 5 valence electrons. Knowing this, you can determine the molecular geometry of each of these structures within ethylamine. So the leftmost carbon is a tetrahedral because it is attached to 3 hydrogens and the centermost carbon, which has 1, 2, 3, 4 bonds, and tetrahedral means 4 bonds. I went too far. And then on the middle carbon is the molecular geometry is also tetrahedral because it has 4 bonds between 2 hydrogen, the C, and the nitrogen. And the nitrogen that is on the left has a molecular geometry of a trigonal planar. As I said, there is a total molecular geometry of, there is a total valence electron count on the structure of 20 valence electrons, but only 18 electrons are displayed. There is actually a valence electron pair that is on the nitrogen. And so this would be the completed Lewis dot structure, including the 2 valence electrons that is on the amine or the NH2 group. To get a better perspective of what this looks like, let's look at the 3D molecular structure of ethylamine. So here, as you can see, this is the Lewis dot structure that I was showing you. This is it in more simplified terms. You have your CH3 that is on this end highlighted in the green. In the center, you have CH2, which is highlighted on this point in the center. And on the right, you have nitrogen, your amine group, which is highlighted in the blue, and your hydrogen, which is highlighted in the gray. So on the right screen, you can see, compared to the 2D structure, this is the 3D structure. If I turn it the right direction, this is what it looks like, word for word what it looks like over on the 2D structure. So the hydrogen, as I stated, are the smaller ones, and there are 7 of those. And on the middle, you have the 2 carbons, and then you have the 1 blue hydrogen. Seeing it now in the 3D structure compared to the 2D, you can see how these atoms bond together and how they each of the C have a tetrahedral molecular geometry and the nitrogen have a trigonal planar geometry. And also the white represents the bonds as shown here. And the valence electrons would be on the opposite side of this bond to minimize repulsion as much as possible. So now that we have seen the 3D molecular structure, let's look at some of the chemical and physical properties that make ethylamine what it is. So the molecular weight of ethylamine is 45.1 grams. The state of matter that ethylamine can be found in at room temperature, at standard room temperature and pressure, is as a colorless gas, or if it is in the form of a liquid, it will be water white, which also its state of being a water white liquid can also be indicative of its solubility. Whereas its density is 689 kilograms over m cubed. Its melting and boiling point is 32 degrees Fahrenheit, and its freezing point is negative 114 degrees Fahrenheit. As I had stated before, the solubility of ethylamine is miscible, which means that it will form a homogeneous mixture that when it is added together with a pure liquid. And since the other valence electron, depending on what it is combined with, it can act together as basically on this electron pair, it can act together to form either a mixture, just depending on what it is added with, and when it forms a homogeneous mixture together when it is that of a pure liquid. So the acidity of ethylamine in pKa is 10.8, which is for the conjugate acid of ethylamine. So this has been the overview of the 2D and 3D molecular structures and the chemical and physical properties. But what applications does this have to the field of chemistry, and what does this have overall in life? Well, Frank is going to go further in explaining how this can apply to chemistry and what are some applications of it. Thank you so much for watching.
All right. So ethylamine, which is also known as ethanamine, has some important fields related to chemistry. Now, to start off with, specifically with tea roots, it has a chemical reaction involved between three substances, where ethylamine serves as a precursor. So the way this chemical reaction works is L-alanine is converted to L-gumite, which is then produced as an L-theanine. But in the step between L-glutamate and L-theanine, ethylamine takes place within that step to serve as a precursor, which allows this chemical reaction to occur, which also contributes on how this tea is able on the tea's ability to do its function and its taste. Now, ethylamine can also be stabilizes rubber latex to produce rubber gloves. In addition, the substance within this substance in the form of liquid can be used as a solvent to refine petroleum and vegetable oils. Now, application or usage of ethylamine includes the following on how this substance is popular with agrochemical field, or also known as the agricultural field, mostly due to the concept of economics and how farmers wish to improve efficiency and production to keep up with the demand of consumers. Now, a specific example is that ethylamine is a precursor, such as how it's a precursor for tea roots through atrazine, zemazyne, and zynozyne to produce weed killers. Now, ethylamine can also behave as a catalyst to speed up the rate of production of polyurethane foam and in dyes as well. Now, here's the 2D structure of ethylamine again, but more specifically, I will utilize this to identify the molecular properties. Now, starting off with the functional group, as we can see, the central atom that's furthest to the right is nitrogen, and it's bonded to two hydrogens. Therefore, it is considered an amine group. Now, before I count, I determine the number of sigma and pi bonds. Single bond means 1 sigma bond, 0 pi bonds. Double bond, 1 sigma bond, and 1 pi bond. A triple bond means 1 sigma bond and 2 pi bonds. Now, with this in mind, carbon 1 and carbon 2, they both have 4 electron domains, and they're all single bonds. Therefore, we have 4 sigma bonds, but 0 pi bonds. Now, nitrogen, on the other hand, although it has three single bonds, it still has 4 electron domains due to the fact that it also has a lone pair. Now with that being nitrogen only having 3 single bonds it has only sigma bonds then, and no pi bonds. Now, only having sigma bonds tells us that the hybridization of all three central atoms is sp3. And now to determine the shape of said central atom, for carbon 1 and carbon 2, it'll be tetrahedral due to both of them having 4 electron domains. And then nitrogen, although it has 4 electron domains, it has that lone pair, so it has a shape of a trigonal pyramidal. Now, although the carbon and nitrogen have slightly different shapes, they both share the same bond angle of 109.5. And then when it comes to polarity, the molecule can either be partially nonpolar, partially polar, overall polar, or overall nonpolar. So with that in mind, we'll consider the polarity of each individual central atom. Now to start off with carbon 1 and carbon 2, they're both considered polar. Now, considering the polarity of nitrogen, on the other hand, it's also considered as being polar. Now, since all three central atoms are polar, then ethylamine as a whole can be considered as a molecule that's overall very polar. And now here's my slide with the references and citation. Thank you.